Hi and hello students. Today we are going to start the part 5 of the coordinate geometry, that is slope formula. Here we are going to use to find the slope of any line by two ways. The first way, if the measure of the angle is given, then slope formula is different, and if the coordinates are given, then the formula is different. Suppose if the angle of inclination is given 30 degree, then we have to find out the slope. If angle is given, then slope of line equals to tan theta. This is the formula. But remember that it is only used if the angle's measurement is given then. Okay. If I write the slope of the line equal to tan theta, then we must know tan 30, then tan 45, tan 60 and tan 90. Tan 30 is 1 upon root 3, tan 45 is 1, tan 60 is root 3 and tan 90 is not defined. These are the values of tan. Okay, but if the coordinates are given then we have to use different formula. Slope of line, remember that if the coordinates are given, then we have to use this one formula. Slope of line equals to y2 minus y1 upon x2 minus x1. This is a simple formula to find the slope of any line. Now, let me tell you what are the uses of this one. We can show it to find slope of a line. This is the first use of the slope of line. Then to show points are collinear, and then the last part of this one is type of collateral. In collateral, only one we can show it, that is parallelogram. For other types of collateral, we cannot use slope of formula. If only the parallelogram is given, then we can show it by parallelogram. And the last use of this one, to show the lines are parallel. These are the four uses of this formula. First one, to find the slope of any line, to show the points are collinear, to show the parallelogram, and to show the lines are parallel. Let's see the example number 1, which is depend upon the angles. Here we have to find out the slope of line and the angle is given. Therefore, we can write it slope of line equals to tan theta. Instead of theta, you have to write it 30. So tan 30. Tan 30's value is 1 upon root 3. Therefore, we can write it slope of line equals to 1 upon root 3. Let's start with the example number 2. Here, the coordinates of A and B are given. So, we have to use the second formula. First, you have to write the coordinates A minus 1 and minus 1. B's coordinates are 0 and 1. So, here you have to write it x1 equals to minus 1, y1 equals to minus 1, x2 equal to 0 and y2 equals to 1. Therefore, slope of line AB equals to, which is the formula? y2 minus y1 upon x2 minus x1. Now substitute the values. y2's value is 1, then minus sine y1 value is minus 1, so it should be in bracket. x2 is given 0, then minus x1 value is minus 1, so it should be in bracket. Then we will get minus. If the minus sign is outside the bracket, you have to change the inside one. So it should be converted into plus 1. Same for this one, 0 plus 1. So we'll get it 2 upon 1. 2 upon 1 means what? 2. Therefore, the slope of line AB equals to 2. Slope of line AB equals to 2. Let's start with the example number 3. This is the second use of the slope formula. Here you have to show that the points are collinear. When the points are collinear, if their slopes are same. If the slopes are same, then these points are collinear. It means here we have to show that the slope of DE should be equal to slope of EF. If they are equal, then these points are collinear. Otherwise, they are not collinear. So let's write it. D's coordinates are minus 2, minus 3. E's coordinates are 1 and 0. So here we have to write it x1 equals to minus 2, y1 equals to minus 3, x2 equals to 1, y2 equals to 0. Therefore, slope of line DE equals to y2 minus y1 upon x2 minus x1. So now substitute the value. y2 is 0, then minus sign, then y1 is minus 3, then x2 is 1, then minus sign, and x1 is minus 2. It should be in bracket. So I told you that if the minus sign is outside, then you have to change the inside. So 0 plus 3, and here 1 plus 2. 0 plus 3 means 3, and this is 1 plus 2 is 3. Therefore, we'll get the slope of line DE equals to 1. Now give the number 1 here. Now here we are going to find out the slope of EF. Same method you have to write the coordinates of E, 1, 0, and F's coordinates are 2 and 1. x1 equals to 1, y1 equals to 0, x2 equals to 2, and y2 equals to 1. Therefore, slope of line EF equals to y2 minus y1 upon x2 minus x1. So y2 is given 1, y1 is given 0, x2 is 2, minus x1 is 1. So 1 minus 0 is 1, 2 minus 1 is 1. So you'll get the answer 1. Give the number 2. Here we can write it slope of line EF. You'll get it 1. So from 1 and 2, you will get the slope of line DE equals to slope of line EF. Slope of line DE equals to slope of line EF, and therefore D, E, F are collinear. I told you that if their slopes are same, then these points are collinear. Let's start with the next example. Here we are going to show the parallelogram by slope formula. In first one, you have seen that we can show the parallelogram by distance formula also and by slope formula also. But it is very useful that it is a shortcut method by using a slope method to show the parallelogram. So let's start. Here the coordinates of A are given minus 4 and minus 7, and B's coordinates are minus 1 and 2. So we can write it x1 equal to minus 4, y1 equal to minus 7, x2 equal to minus 1, y2 equals to 2. slope of AB equals to y2 minus y1 upon x2 minus x1. So substitute the value. Y2 is 2, minus y1 is minus 7, x2 is minus 1, and then in bracket you have to write the value of x1 as a minus 4. Here we will get it 2 minus minus, so it will be plus. Minus 1 will remain as it is, and this will be converted into plus. So you will get it 2 plus 7 is a 9, and minus 1 plus 4 is a 3. 3 3 is a 9. Give the number 1. Slope of line AB is 3. Now we are going to start for BC. B's coordinates are minus 1 and 2. C's coordinates are 8 and 5. x1 equals to minus 1, y1 equals to 2, x2 equals to 8, and y2 equals to 5. Slope of BC equals to y2 minus y1 upon x2 minus x1. y2's value is given 5, then minus sign, y1 is 2, x2 is 8, then minus sign, and x1 is minus 1, so you have to write it in bracket. So 5 minus 2 will be as it is. 8, this minus will be converted into plus. 5 minus 2 is 3. 8 plus 1 is 9. 3 ones are 3 threes are. This is slope of line BC equals to 1 upon 3. Give the number second. Now we are going to find the slope of CD. Here C's coordinates are 8 and 5. D's coordinates are 5 and minus 4. x1 equals to 8. y1 equals to 5. x2 equals to 5. y2 equals to minus 4. Slope of CD equals to y2 minus y1 upon x2 minus x1. y2 is given minus 4. Then minus sign, and y1 is 5. x2 is given 5, and then x1 is given 8. So minus 4 minus 5 sign are same, addition and give the sign of larger number. So it should be minus 9. Then again this is plus and this is minus, subtraction and give the sign of larger number. This is minus 9 and minus 3. So 3 ones are and 3 threes are. So you get it minus 3 and minus 1, but minus minus will be converted into plus. Slope of CD equals to 3. Give the number 4. Now we are going to find out the slope of AD. A's coordinates are minus 4, minus 7. D's coordinates are 5, minus 4. x1 equals to minus 4. y1 equals to minus 7. x2 equals to 5. And y2 equal to minus 4. Slope of AD equals to y2 minus y1 upon x2 minus x1. y2 is given minus 4, then minus sign, y1 is minus 7, so it should be in bracket. x2 is 5, then minus sign, and then it is minus 4. Minus 4 will be as it is, this will be plus. Then 5, again it will be plus. Here we will get it 7 minus 4 as a 3. 5 plus 4 as a 9. So here we will get it 3 ones are 3 threes are. Slope of CD equals to 1 upon 3. Give the number 4. From 1 and 3 and 2nd and 4. From 1st and 3rd, slope of AB equals to slope of CD. From 2nd and 4th, slope of BC equal to slope of AD are same. Here you will get it. AB equals to 3, CD equals to 3. BC equal to 1 upon 3 and CD equal to 1 upon 3. Therefore, their slopes are same. Therefore, we can say that line, either segment AB is parallel to segment CD and segment BC is parallel to segment AD, and therefore quadrilateral ABCD is a parallelogram. Let's start with the different sum. Here the slope of line is given and you have to find out the value of K. So again you have to use the slope formula. Before that you have to write the coordinates. R's coordinates are 1 and minus 1 and S coordinates are minus 2 and K. X1 equals to 1, Y1 equals to minus 1, X2 equals to minus 2 and Y2 equals to K. Slope of line RS equal to Y2 minus Y1 upon X2 minus X1. Now the slope is given minus 2. So here you have to write the minus 2. Then Y2 is given K, minus Y1 is given minus 1. So it should be in bracket. X2 is given minus 2 and X1 is given 1. Minus 2 will be as it is. This will be minus minus plus. Then sign are same, addition and give the sign of larger number. So here you will get minus 3. Now this is divide, it will be multiply. Minus 3 minus 2, multiplication of minus will be converted into plus. 6 equals to K plus 1. Now 1 comes on this side, 6 minus 1 equals to K. 6 minus 1, 5. So therefore the value of K is 5. Here the line PQ is given parallel to RAS. I told you that if you want to show the lines are parallel, then show their slopes are equal. But here the sum is different. Already the lines are parallel and you have to find out the value of K. It means first you have to find out the slope of PQ, then slope of RAS. So let's start. P's coordinates are 2, 4 and Q's coordinates are 3 and 6. X1 equals to 2, Y1 equals to 4, X2 equals to 3, Y2 equals to 6. Slope of line PQ equals to Y2 minus Y1 upon X2 minus X1. Now substitute the values. Y2 is given 6, Y1 is 4, X2 is 3 and X1 is 2. 6 minus 4, 2. 3 minus 2, 1. So here you will get it 2. Slope of line PQ equals to 2. Now we have to find out the slope of RS. R's coordinates are 3 and 1. S coordinates are 5 and K. X1 equals to 3, Y1 equals to 1, X2 equals to 5, Y2 equal to K. Slope of line RS equals to Y2 minus Y1 upon X2 minus X1. Y2 is given K, Y1 is given 1, X2 is 5 and X1 is 3. K minus 1 will be as it is and 5 minus 3 will be 2. Okay, now see, these lines are parallel. If the lines are parallel, it means their slopes are same. But PQ is parallel to RS. Therefore, slope of PQ equals to slope of RS. Now substitute the values. PQ is given 2 and slope of RAC is k minus 1 upon 2. Now these 2 will come on this side, so it will be multiplied. Equals to k minus 1. Minus 1 will become on this side. So 4 plus 1 equal to k. Therefore, k's value is 5.